The Honorable Mr. Weli Ardiansyah, my beloved friends, and everyone who watched this video. Good day. First of all, my name is Winda Permata Putri from 5BA class. In this great opportunity, I would like to explain and present about a hypothesis. When watching a drama or reality show on television, have you ever guessed what will happen to the main character at the end of the story? If so, on what basis did you make this guess? In this life, there are many things that make us often guess what will happen next. Often, these assumptions arise because of experience of the same thing, or at least similar to the events or story we are facing. In the research, guess also often arise. These assumptions is more often referred to as a hypothesis. Well, what is a hypothesis? A hypothesis is a tentative statement about the relationship between two or more variables. The hypothesis is a prediction, but it involves more than a guess. Most of the time, the hypothesis begins with a question which is then explored through background research. This is only at this point that researchers begin to develop a testable hypothesis. Hypothesis should be based on existing theories and knowledge. It also has to be testable, which means we can support it through scientific research methods such as experiments, observations, and statistical analysis of data. Now we go on to the variables in hypothesis. Since we know that hypotheses propose a relationship between two or more variables, they are an independent variable and dependent variable. An independent variable is something the researcher changes or controls, while a dependent variable is something the researcher observes and measures. Let's talk more detail. The independent variable is the variable the experimenter changes or controls and is assumed to have a direct effect on the dependent variable. Two examples of common independent variables are gender and education level, while the dependent variable is the variable being tested and measured in an experiment and is dependent on the independent variable. An example of a dependent variable is depression symptoms, which depends on the independent variable. It is type of therapy. Let's take an example. Daily apple consumption leads to fewer doctor's visits. In this example, we can see that the independent variable is apple consumption since it's the assumed cause, while the dependent variable is the frequency of doctor's visit since it is the assumed effect. After knowing what hypothesis is, now let us know about how to develop a hypothesis. The first is ask a question. Writing a hypothesis begins with a research question that we want to answer. The question here should be focused, specific, and researchable within the constraints of our project. Let's take an example. Do students who attend more lectures get better exam results? Well, let us keep the question first and now we go on to the second step. It is do some preliminary research. We should also conduct preliminary research on our topic and ask ourselves what gaps, problems, or puzzles emerge. Investigate our topic by doing a broad literature review on our topic. Broad does not mean reading dozens of scientific articles word for word. We can begin with a general internet research, establish keywords about our topic, and search using those keywords. A general information search should uncover what is currently known on our topic and should uncover areas where we could probe further. Read related research from the same field or even from similar research project. What can we learn and what remains unanswered by those articles? Well, while speaking with researcher and doing general information researching, we should remember the following. The first, if we are able to answer our preliminary research question or questions just by speaking to a person or reading a general internet article, we will need to redevelop our research question because it's too simple. And the second, if we cannot find any information on our topic and no one is knowledgeable enough to speak to us about the topic, we are likely examining something too specific. Redefine our research question and begin our preliminary research anew. The third step is formulate and refine the hypothesis. Here, we need to make sure that our hypothesis is specific and testable. There are various ways of phrasing a hypothesis, but all the terms we use should have clear definitions, and the hypothesis should contain the relevant variables, the specific group being studied, and the predicted outcome of the experiment or analysis. Last but not least, the fourth step is phrase our hypothesis in three ways. The first way, to identify the variable. We can write a simple prediction in if blah 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 then form. The first part of the sentence states the independent variable and the second part states the dependent variable. If we see from our example before, it will be if a first-year students start attending more lectures, then their exam scores will improve. The second way is in academic research, hypothesis is more commonly phrased in terms of correlation or effects, where we directly state the predicted relationship between the variables. For example, the number of lectures attended by the first-year students has a positive effect on their exam scores. And the third way, if we are comparing two groups, the hypothesis can state what difference we expect to find between them. For example, first-year students who attended most lectures will have better exam scores than those who attended few lectures. After we develop our hypothesis, now let's test our hypothesis. At this point, we already have a hypothesis ready to go. Now it's time to test our theory. We should remember that a hypothesis is a statement regarding what we believe might happen. These are the steps we will want to take to see if our suppositions stand up. Number one, state our null hypothesis. The null hypothesis is a commonly accepted fact. It's the default, or we would believe if the experiment was never conducted. It's the least existing result, showing no significant difference between two or more groups. Researchers work to nullify or disprove the null hypothesis. Number two, state an alternative hypothesis. We will want to prove an alternative hypothesis. This is the opposite of the null hypothesis, demonstrating or supporting a statistically significant result. By rejecting the null hypothesis, we accept the alternative hypothesis. Number three, determine a significance level. This is the determiner, also known as the alpha. It defines the probability that the null hypothesis will be rejected. A typical significance level is set at 0.05 or 5%. We may also see 0.1 or 0.01 depending on the area of the study. Let's see, if we set the alpha at 0.05, then there is a 5% chance we will find support for the alternative hypothesis, thus rejecting the null hypothesis when, in truth, the null hypothesis is actually true and we were wrong to reject it. In other words, the significance level is a statistical way of demonstrating how confident we are in our conclusion. If we set a high alpha of 0.25, then we will have a better shot at supporting our alternative hypothesis, since we do not need to find as big a difference between our test groups. However, we will also have a bigger chance at being wrong about our conclusion. Number 4, calculate the p-value. The p-value, or calculated probability, indicates the probability of achieving the results of the null hypothesis. While the alpha is the significance level we are trying to achieve, the p-level is what our actual data is showing when we calculate it. A low p-value offers stronger support for our alternative hypothesis. And number 5, draw a conclusion. Here, if our p-value meets our significance level requirements, then our alternative hypothesis may be valid and we may reject the null hypothesis. In other words, if our p-value is less than our significance level, for example, if our calculated p-value is 0.02 and our significance level is 0.05, then we can reject the null hypothesis and accept our alternative hypothesis. Let's take an example. It's about vitamin C. Is it true that vitamin C has the ability to cure or prevent the common cold, or is it just a myth? There's nothing like an in-depth experiment to get to the bottom of it all. A potential hypothesis test could look something like this. The null hypothesis is children who take vitamin C are no less likely to become ill during flu season, while the alternative hypothesis is children who take vitamin C are less likely to become ill during the flu season. The significance level is 0.05, while the p-value is calculated to be 0.20. So, we can conclude that after providing one group with vitamin C during flu season and the other with a placebo, we record whether or not participants got sick by the end of the flu season. After conducting our statistical analysis on the result, we determine a p-value of 0.20 that is above the desired significance level of 0.05, and thus we fail to reject the null hypothesis. Based on our experiments, there is no support for the alternative hypothesis that vitamin C can prevent colds. Well, ladies and gentlemen, after all, the hypothesis is a critical part of any scientific exploration. It represents what researchers expect to find in a study or experiment. In situations where a hypothesis is unsupported by the research still has a value. Such research helps us better understand how different aspects of the natural world relate to one another. It also helps us develop new hypotheses that can then be tested in the future. Well, ladies and gentlemen, that's all about my explanation. Hope this will be useful for us. Thank you very much for your attention. Have a good day. See you and wassalamualaikum warahmatullahi wabarakatuh.